Welcome to the free Flutter course. In this tutorial, we'll continue exploring classes in Flutter, focusing on an essential concept: inheritance. Inheritance allows us to create new classes based on existing ones, making our code more flexible and reusable. For instance, imagine you need to create several classes with common properties. If you want to create classes for different types of vehicles, such as a bicycle and car, you can use inheritance to extract shared attributes like speed. Let's see how this works. First, we declare a vehicle class and define the speed property along with the constructor. So far, everything should be familiar. Next, we'll create a car class that inherits from the vehicle class. Notice that to do this, we use the extends keyword followed by the class name we are inheriting from. This means our car class inherits all the properties and methods of the vehicle class. In this case, just the speed variable. We also need to define a constructor in the car class, but in a slightly different way. Instead of using this, we'll use the super keyword. Super allows us to reference the properties and parameters of the parent class from which we're inheriting. Here's how the constructor looks. We can also initialize values in the constructor using the syntax we learned earlier through a colon. This time, however, after the colon, we need to call the parent class constructor using the super keyword followed by parentheses. This approach is useful if, for example, we have a named constructor that takes no parameters. In that case, we must call the parent class constructor to initialize its fields. Now, let's add a door count variable to our car class. Notice that we need to declare it in our constructors, and there are two ways to do this. First, we can initialize it using this as we did before in the first constructor. The second option, which we've also covered, is to initialize it after the colon. But we have to declare our variable first and then call the parent class constructor. Remember that the parent class constructor is always called last. First, we initialize our variable. Then, separated by a comma, we call the parent class constructor. Next, let's create a bicycle class that also inherits from the vehicle class. This class will have a handlebar height field. We'll create a constructor where we declare its field using this and the parent's field using super. Now, let's create instances of these classes using the syntax we're familiar with. First, we'll create a car, passing the required parameters to the constructor. Then, we'll create a bicycle. Let's try to print out the properties of the car. Notice that we can access both the speed and door count properties. Let's give it a try. Now, let's print the information for the bicycle. This time we can access the speed and handlebar height properties. Here's the result. As we can see, we've made it so that our classes are created based on the template class vehicle while still having their unique fields. However, there's one issue. We can create an instance of the vehicle class by passing in a speed value. Logically, this doesn't make sense since vehicle is just a template. To prevent this, we can make our class abstract. By doing so, everything remains the same, but we won't be able to create instances of the vehicle class. To do this, we use the abstract keyword. Now, if we try to create an instance of the vehicle class, we'll get an error. Next, let's talk about methods. As an example, let's create a method in our vehicle class that prints the speed. Notice that we can access the variables of the current class, but we don't have access to the child class variables within the parent class. For instance, the door count variable from the car class. Once we've written this method, we can use it. Let's give it a try. As we can see, it works. But what if we want the parent class method to behave differently in each child class? For this, we use method overriding. We need to use the @override annotation. Then, we implement the method as needed, almost as if we're rewriting the method, but with different internal logic. The @override annotation isn't mandatory. You can override methods without it. However, it's helpful for code analysis and readability. Let's override the method in the child classes. We'll do the same thing, just adding a small prefix to make it clear when testing. Notice that we can access parent class variables within the child class. We can reference them using super or directly. Let's run our program again. Now we see that the same method works differently in different child classes. By the way, in abstract classes, you don't have to implement a method. You can simply specify the method type and parameters using a semicolon instead of a method body. This forces the method to be implemented in any class that inherits from it. If we implement the method as we did before, there's no need to override it in the child class. When creating class instances, we typically create a variable with the corresponding type. However, when creating instances of classes that inherit from another class, we can declare the variable as the parent class type while initializing it using the child class constructor. We can do this because in Dart, all child classes are considered partly as instances of the parent class. For example, any car is considered a vehicle. However, we can't do the reverse. Declare a variable as a car type and use the vehicle constructor, because not every vehicle is a car. A car has specific properties, such as the number of doors, which not every vehicle, like a bicycle, has. Let's check how an instance of type vehicle behaves when created using the car constructor. First, notice that we can only access the variables and methods of the vehicle class. even though it was created using the car constructor. Let's try calling the method to print the speed. As we can see, even though the object is of type vehicle, the method behaves as we defined it in the car class. This is very useful and helps us avoid repeating code. For example, we can create a list of type vehicle and add 2 cars and 3 bicycles. Now, using a for-in loop that we covered in previous lessons, we can iterate over all elements and call the method to print the speed. Notice the result. What happened is that when we iterated over a car, the method from the car class was called, and when we iterated over a bicycle, the method from the bicycle class was called. Now, I'd like to give you a small task. Create an abstract class animal with a method to make a sound. You'll need to create 3 child classes of your choice, each of which will override the parent class method. Next, create a list of animals and use a loop to call the sound method on each one. Pause the video and try to solve this task. To solve this, create an abstract class animal with a void method that doesn't take any parameters. Then create 3 classes: cat, dog, and frog. In each of them, inherit from the abstract class and override the method. Next, create a list in the main function and fill it with animals. After that, use a for loop to iterate over all animals and call the sound method on each. Let's check. As we can see, everything works. Today, we delved deep into inheritance in Dart and Flutter, covering key topics like using the super keyword, constructors and inheritance, abstract classes, and more. These concepts will help you build more flexible structures in your applications. Don't forget to practice. The more you use inheritance in your projects, the better you'll understand how to apply it correctly. Subscribe to the channel, give a thumbs up, and share your thoughts in the comments. See you in the next lesson.